Now, alright, here in this section, we are going to study that what is hotspot technology. So, we'll be just studying about the hotspot technology. Alright, so actually JDK 1.0 was released, and initially Java was a interpreted language. So, people started talking about that since it is an interpreted language, so Java is a slow language. But anyways, and soon the Sun Microsystem, they upgraded the Java language, and they made it a hotspot technology. It was introduced with the hotspot technology. They introduced with the hotspot technology in Java. Now, what is the hotspot technology? And even if you see currently the Java version, if you just type in the command prompt java/version, you can see Java hotspot trademark. You can see Java hotspot trademark, right? So Java is a hotspot technology. Alright, so we need to understand that what is actually the hotspot technology, right? And how does it benefits us? So basically, when we start programming, there is a simple program test.java. Now this test.java will be compiled into test.class. It will be compiled into test.class using the Java-C program. It will be compiled into test.class, right? Now, once it has been compiled into test.class, this .class file will be read by JVM. JVM is going to read this .class file, right? So easily the JVM will load this .class file into the memory first. It will load it into the memory, and then after loading into the memory, basically it will actually divide. In fact, it will compile it into the source native code or the machine code. This JVM is going to compile it into the machine code. And here is the main part, that when it is compiling into the machine code, right? So this job is done by either interpreter or by compiler. And interpreter will basically, if you see, interpreter is going to interpreter will read line by line and convert it into machine code, while a compiler will read the complete code and it will convert it into machine code. So it will load the class into memory, convert it into machine code, and then basically when it is converted into machine code at that specific time, JVM has one interpreter and one compiler, right? So it is having a compiler and it is also having an interpreter. So basically, why it is using a compiler and interpreter? There are some codes that are fast in interpreter, while there are some codes that are fast in interpreter. So what JVM is going to do, JVM will divide the same source code in between compiler and interpreter. It will divide the same source code in between the compiler and interpreter, right? The code that will run fast with compiler will be given to compiler, and the code that will run fast with interpreter will be given to interpreter. So the same program is being divided into compiler and interpreter, or we can say the technology where compiler and interpreter are acting together. They are acting together. That will be known as the hotspot technology. We will call it a hotspot technology. So JVM divides the code between interpreter and compiler, and this specific technology we call it the hotspot technology. Now basically they both will work to produce the output, and this is the output we are seeing. So this will enhance the performance. This is definitely going to enhance the performance in between the compiler and interpreter. Right. Now basically, so JVM will divide the code in between interpreter and compiler, and now if you can just see here that some code it runs fast on interpreter while some code runs fast on compiler. So the code that runs fast on interpreter. There is some code that will run fast on interpreter, while some code will run fast on the compiler. So code that runs fast on compiler is given to compiler basically, or we can say that JVM will divide the code, the necessary code, between compiler and interpreter, between interpreter and the compiler. Right? It will divide the necessary code between interpreter and compiler to boost the performance. This technology is known as the hotspot technology. We call this technology as the hotspot technology. Right. Now basically what we can see here is, this is what is the hotspot technology that is present with us. Java is, we can discuss the more features of Java. So first and foremost thing, that Java is a complete object oriented programming language. It is a complete object oriented programming language. Now what is OOPS basically? So OOPS stands for object oriented programming language, or OOPS is object oriented style. It is a style of programming. It is just a style of programming and nothing else. It is a style of programming using which we can write more managed code. Basically it manages the code very well, manages a huge code very well. And another use is that the real-time objects can be represented using OOPS objects. So OOPS helps in coding so that we can modelize, or we can represent the real life entities in programming world, so that we can easily idealize all these things, real life entities, into programming. Various features of OOPS are, it has classes, it has objects, and it has encapsulation. It follows with your so-called data abstraction, and we have inheritance. We go with message passing and dynamic dispatch, polymorphism, and the dynamic dispatch. So these are some of the important points, or in fact the most important points of OOPS. Now what is a complete OOPS language? So basically a language that follows all the features of OOPS very strictly is known as a complete object oriented language. So a complete object oriented language, programming language. So a language that follows all the features of OOPS, or that is rules, basically features or rules of OOPS very strictly, is complete OOPS. Example, Java and C#. And what is partial OOPS language? Partial object oriented language. So a language that follows only the partial rules of OOPS. It does not follow the complete rules of OOPS. It follows only the partial rules of OOPS, means it may follow or it may not follow, or it may follow some rules, maybe not all, or it may not follow all the rules very strictly. For example, we have is C++ and PHP. Right. Example we can easily take is C++ and PHP. In Java and C#, if you see, all the code is written inside a class. Even if we have to print a simple statement, that have to be written inside a class only. Whereas even to print a single statement, we need to write a complete class and a method inside it, or a function we can call. Function inside a class is a method. So we need to write a complete function inside it. Now it follows rules of OOPS, maybe not all or maybe not strictly. So example, we can just say C++ or PHP. So we may write the programs using oops or without using oops also. So if you want to, you can simply write it inside the main, or if you want, you can write a class and a method inside it and that make the object and then call. So one is the object oriented way and other is simple procedural way. So whatever you want, we can just follow it. So but Java is a complete OOPS language. Java follows all the rules of OOPS very strictly. It is a complete object-oriented programming language, and it follows all the rules of OOPS very strictly. It is a complete object-oriented language. It follows all the rules of OOPS very strictly. Now basically, there are some features that Java does not follow. Even Java has left few features due to, since these features are not included, these OOPS features are not included. So some people may even argue that Java is not complete OOPS. What are those features? Those features have been left just to decrease the complexity. Since these features make programming more complex, that is why they have been left. For example, we are having operator overloading, and we also have the multiple inheritance. We also go with multiple inheritance. So these are two features that Java has left out. Both the features have been left to avoid confusion and complexity in programming. But multiple inheritance is avoided through classes, but it can be achieved through interfaces or by writing manual inheritance. You can easily achieve all these things using manual inheritance. So since these two features are not present, so some people may even argue that Java is not complete OOPS language. Yes, these two features are not present, and these two features have been removed to decrease the complexity inside a programming language. We may also say that Java is high performance and a robust language. That Java provides high performance for running the code. Now Java provides high performance, and Java is high performance and a very robust language. Now why Java is high performance and why it is a robust language? We need to understand these points. There are various things that contribute to its high performance. Now first and foremost thing, JVM. JVM makes Java very robust. JVM is a program that runs the code. In fact, it provides just-in-time compilation, and it also takes care of the code, right? It runs the code and it also takes care of the code while it's running. It provides many runtime services to the code. If you can just take an example, so memory management. So if we want to perform memory management in C and C++, we will have to write our own code. But in Java, this is not the case. Memory management is automatically done using our JVM. It is automatically done using JVM. So memory management, right? In C and C++, we need to write our own logic for it. But in Java, this memory management is provided automatically. That is, memory will be automatically allocated to the program at runtime. It will be also deallocated at runtime, and JVM will also run a garbage collector when it finds that there is no more memory for a new program. So it will also run a garbage collector. Second is like handling runtime errors and exceptions. In C and C++, handling the runtime errors and exceptions, we need to write a separate code again for this. If we are not writing any code, it results into the crash of a program. But this is not the case in Java. So it does not result in the crash of the program. Basically, it has a default exception handler, or you can understand the point that it will not result in the crash of the program. It provides a beautiful mechanism for handling errors and exceptions. Next is security. So JVM will take care of the program while it is running. That is, it will provide security to your program. What kind of security? Like the other, when your program is running, other program will not be able to access it, or any virus or any Trojan will not be able to affect your program at the time of running. So it won't allow illegal access of data or even resources. Resources means files and all those things. So all these things is inbuilt in JVM. These services are provided by JVM inbuilt. So all the necessary security that is needed is provided already by the Java at runtime. Right. So all these services are provided by Java at runtime. Now basically what we can see here, that even from security point of view, the pointers have also been removed from Java, since pointers are they increase the complexity, and they are a loophole in the security also. So that is why from security point of view, pointers have been removed. So all these features completely make Java a very secure programming language. So Java does not uses pointers. It does not uses pointers, since pointers are a loophole in the security. So it does not use pointers, since they are a big loophole in the security, right? And they also tend to increase the complexity. They also increase the complexity of the programs. Hence, for all these reasons, the pointers have been removed. The Java does not use pointers. All the necessary security is provided by Java at runtime. Now, memory management. We will just discuss few things about memory management, because garbage collector is related to memory management itself. So what is garbage collection basically? So garbage collection in C and C++ to initialize memory. Yeah, we already discussed it. Memory at runtime, we need to write and to destroy it also. At runtime, we need to write our own code for it. We need to write our own code for it. In Java, memory management is automatic. And if JVM finds that the program is falling short of memory, what it will do is it will run a program known as garbage collector. We'll just talk about garbage collector. So automatically memory is initialized at runtime when needed, right? And memory is also deleted. So how does memory delete it? So this is done by garbage collector. What is garbage collector? Garbage collector, it's a program of JVM that always keeps on running in the background. It always keeps on running in the background. It's a program. It always keeps on running in the background. And basically, when it hunts for the unused memory. Now, there may be some memory that is occupying space, but it is no more in use. So it is the unused memory. So any unused memory that is present, so garbage collector will set that unused memory free. So it will set that unused memory free. So this is what is garbage collector. So it's a program of JVM. It always keeps running in the background while programming. It will set the unused memory free, and this free memory can be used by other programs. Obviously, the free memory can be used by other programs. Now, the system will never fall short of memory. You might have seen many programs that indicate that enough memory is not available and all those things. So while you are working with all these things, your program will never fall short of memory in any case. So it always keeps running in the background when program is running. It will set the unused memory free. This memory can be used by some other programs. So system will never fall short of memory. Right. So all these points and all together they contribute to the robustness of our programming language. So all these features will definitely help in making the Java programming language